Okay, so hello everyone. Today we'll be starting with our first lecture. In this series, we'll be doing certain questions on Newton's laws of motions, and we'll be understanding what basically are these and their essence. Okay, so our focus in this series will be on three factors. Pardon me for my writing. First will be on understanding them. Like if you are doing it for like classes and all, like I will refer you to some other channels you can see, but here we will focus mainly on the understanding of them on the conceptual level. Second thing, we will be applying them to real life problems. And the third thing which we are going to do is that we are going to see that how these shape our modern physics and how these are used and whether these are relevant or not. Okay, so without any wasting any more time, let us start with the very basic concept of the Newton's laws of motion. So Newton has three laws. We'll be going over them one by one. First law is that an object in rest remains at rest, and the one moving with constant velocity keeps moving. But here the condition is this, which is a quite important condition. The condition is that f external is 0. It means still there is no acceleration, there will be a uniform motion continue. So this is quite a important result in our physics and an important law in our physics, because this law defines what is inertia is. So basically inertia is the ability or tendency of a body to resist change in its uniform state of motion. Okay, so this is basically the law that if f external is 0, then the object will keep on moving. So this is law in real life. What we can say about this law is that this is the law which limits perpetual motion machine. When you must have heard about the perpetual motion machine. It is a machine which keeps on performing the work without any energy input. So we see here, as per this law, that it will only happen when there is no external. But we need to understand there is always no object on earth is such that no F external is acting on it. So on every object the external force acts. So in the daily life we can see many examples of the external force. Let us say friction. Okay, gravity is also a type of external force. And if we see the Coriolis force, which is also acting, the centrifugal force is also acting on the earth's surface. These are basically the forces which I will be also explaining in the upcoming lectures, which are the external force and which act on every object. So since the force is acting on the objects, so the velocity should change as per the first law. So in this way we can see the real life examples of the first law of motion. So first law of motion also defines what an inertial observer is. So if we see inertial observer, this is slightly connected to the second law of motion. So basically what happens here is this thing, that the inertial observer is that one for which, for who f is equals to 0 implies a is also equal to 0. So what does this mean? Let us say there is a thing resting here. Okay, there is a, let us say there is an apple here which is at rest. It has only one force here. The acceleration is equal to g. No horizontal acceleration it has. And now I am here. Okay, and I am seeing this apple and I am running here with acceleration a. So what I will be observing is that this apple is moving towards this direction. So for me moving with the acceleration f is equals to ma, but actual acceleration on the object is equals to 0. So this, if this is me, I am not an inertial observer. And on the other hand, let us consider this case that when there is a apple here, it is at rest, ah is also equals to 0. Now what happens is there is a observer who moves with a constant velocity v. So for him it is also moving with a constant velocity v, but see here acceleration is equal to 0 because for him acceleration is equal to 0. So okay, so these are vectors. So for this acceleration is equal to 0, acceleration is also equal to 0 here. So this is an inertial observer. And the third case is an exercise for you, that you need to find what can be the third case. It is pretty simple. Basically you need to find it. Okay, I am not gonna tell you. So this is this first law of motion, that this is, and why does it imparts, like if you are moving towards a wall, let us say this is related to relative velocity and acceleration. If you are moving towards a wall and this is the wall with velocity v, you just observe yours, just observe that how the wall is appearing to you. See, you are going till here to here, and from your perspective, this is your perspective, you know, if you just see what is happening to the wall is coming here, then it is after some time it is here, at t is equals to 0 it is here, at t is equals to t it is here, and then at t is equals to t, and you are actually going here at time t. So from your perspective it is coming from here. So due to this, that because the velocity is 0, velocity is constant here in this direction, so it will be also constant in this direction. So acceleration will be 0 in both the direction. But if there is acceleration in this direction, then the acceleration must be also there in this direction, which means that force is equal to 0 doesn't apply. This is equal to 0. Now second law of Newton's says F is direction proportional to A and F is directly proportional to M. This is the misconception which we have, but the actually thing is that here we have to just interpret F equals to ma. This is for an inertial observer. Okay, we will soon be seeing that why is it for an inertial observer, because we have seen for acceleration A implies F is equals to ma, that is a inertial observer also. So for this there will be a strict vector treatment of these things, but I don't want to go to there. So in the next lecture I will drive that. So what happens basically is that if this is an inertial observer and if it sees something moving with this velocity, okay, and if this observer also sees something here, okay, and this sees it also here, so actually what we can find is the a net. This is the a net, let us say vector addition a net will be equals to, okay, so this will be, so that this thing will be moving with a particular, okay, this will also move with a particular acceleration, sorry, pardon me. So this is a non-inertial observer, if you can see that, okay, so this will be a plus a from non-inertial frame, so the force should be a net minus a. So in this way we can see this thing and the forces will be defined. Okay, so now let us see for the third part what we choose a nice color. Okay, so third law Newton's basically says that F applied by A on B is equals to negative F divided by B by A. Okay, so what does this thing means? So this thing means that there are two objects here. Let us say one is this, the other is this. It is a circle, it is a square, it is a circle. Okay, and these two collide. So the force which it will be applying on it will be same. Now let us see. Let me give you a problem, and then I will be telling the answer also. There is a mobile put on this box. Okay, and the weight of the mobile is mg, and it is also experiencing force n. So what is the net force? Net force on mobile. So we can see this thing easily, that the net force on the mobile is what? It is 0, because these are balancing. But you need to keep in mind this fact, that keep origin of Newton, origin of Newton force of normal force. It arises from the electromagnetic interaction. Electromagnetic interaction with whom? Between the particles of foam and table. So remember, okay, so remember that normal reaction is not reaction of force between earth and object. Okay, so it is between the f between the object and the surface which it touches. So for today, these are the only things we will be discussing. Over the series of lectures, what I will be covering, let me write those things explicitly somewhere here. Okay, so things which we will be covering in our upcoming series will include, but are not limited to, conservation of angular momentum. Okay, angular momentum in 3D. Basically what we will doing is inertia tensor, moment of inertia, which you must have studied now, that it is a scalar quantity. So we'll be seeing that it is a tensor. What will tensor? Don't worry till now. We'll be covering special theory of relativity by a new approach. Okay, we'll also be doing non-inertial systems. Okay, and we'll also be doing the simpler thing, that is linear momentum, conservation of linear momentum, all these things, rigid body dynamics, and we'll be also solving questions on all these things. So tune for me these things, and if you have any other doubt, you can ask me in the chat box.